Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 11, Unknown Angle Proofs, Proofs of Unknown Facts. Okay, classwork opening exercise. A proof. So there is a vocabulary word. A proof of a mathematical statement is a detailed explanation of how that statement follows logically from other statements already accepted as true. And then we have this word. A theorem is a mathematical statement with a proof. So discussion. Once a theorem has been proved, it can be added to our list of known facts and used in proofs of other theorems. For example, in Lesson 9, we proved that vertical angles are of equal measure. And we know from earlier grades and by paper cutting and folding that if a transversal intersects two parallel lines, alternate interior angles are equal in measure. How do these facts help us prove that corresponding angles are equal in measure? Well, let's see. I'm going to leave that question to you open-ended because there's many different ways to answer that, and I will just leave that to you and I'll move on. And it says in the diagram to the right, if you are given that AB is parallel to CD, so I'm just highlighting these so we can see what we're talking about. And when you want to tell the reader that something's parallel to something else, you put an arrow on them, like so. The two arrows match, therefore the two segments or lines are parallel. So if you're given AB is parallel to CD, how can you use your knowledge of how vertical angles and alternate interior angles are equal in measure to prove that X equals W? Okay, so since we know vertical angles are congruent, I could start off by saying angle W and angle Z are equal. So I could say W equals Z, and the reason vertical angles are equal in measure. Okay, so once we do that, then what we can say is, focusing on alternate interior angles, here's Z, here's X, they're alternate interior. Now I can say Z equals X because alternate interior angles are equal in measure. Okay, so now if we have W equal to Z and Z is equal to X, then we can say W is equal to X. Okay, if A equals B and B equals C, then A equals C. It's the same thing. Okay, reason. And the answer is one of two. You could say substitution. We substituted X in for Z so that W is equal to X, or we could have said the transitive property. So now you have available the following facts. We have vertical angles are equal in measure, W and Z, X and Y. Alternate interior angles are equal in measure, Z and X. Corresponding angles are equal in measure, X and W, or Y and Z. Okay, on page 2, it's asking us to use any or all of these facts to prove that interior angles on the same side of a transversal are supplementary. Okay, so let me just recap what they're saying here. Interior angles on the same side of a transversal, so that'd be like this angle here and this angle here. Notice I used 2 marks on one and one on the other because they're not congruent. One's acute, one's obtuse. And they are supplementary, meaning they add up to 180 degrees. Add any necessary labels to the diagram below and write out a proof, including given facts and statement of what needs to be proved. Okay, so here we go. Okay, so I set up my table here, statement, reason, and first thing we want to do is give our givens. So I want to say segment AB, segment AB is parallel to segment CD. And the reason given. Mark the diagram. AB is parallel to CD. You want to have those little markers there. Let me move that one up a little. Okay, AB is parallel to CD. Given. Now we have the measure of BGH, the measure of angle BGH plus the measure of AGH. So what I'm doing here is there's a straight line here. Let me just show you. We're talking about this line here. Let me do it with a segment so it's neat. We have this segment right here. That's a straight line. And I'm choosing values on both sides of it. So I'm saying BGH plus AGH, the measure of AGH, equals 180 degrees. Okay, reason, linear pairs form supplementary angles. The next thing I want to do is, go back to my pen. So now I know that this angle plus this angle here add up to 180 degrees. Now I know the measure of angle AGH is congruent to the measure of angle DHG, these two. The ones I had marked 2 marks on each. So I'd say the measure of angle AGH equals the measure of angle DHG. And the reason, if parallel lines are cut by a transversal, alternate interior angles are equal in measure. Okay, so there you have it. And then finally, I can substitute in values and finish. I'll do it in green. So the measure of BGH, that's this one, the measure of angle BGH plus, well, I have AGH here. AGH is equal to DHG. So instead of writing AGH again, I'm going to change it to the measure of angle DHG equals 180 degrees. And the reason, substitution property of equality. So BGH plus AGH equals 180, and AGH equals DHG. So I can replace AGH with DHG, and that's how we got it. Now that you have proven this, you may add this theorem to your available facts. So now we know vertical angles are congruent. Now we know alternate interior angles are congruent. Corresponding angles are congruent. And now same side interior angles are supplementary. Okay, on this one it says to use any of these 4 facts to prove that the 3 angles of a triangle add up to 180 degrees. For this proof, you'll need to draw an auxiliary line parallel to one of the triangle sides and pass through the vertex opposite that side. Add any necessary labels and write out your proof. So here's what we're going to do. I'm going to draw a line segment. Now you want to draw it as close to parallel as you can on your paper. I can do that pretty well here with electronics, but it's harder on paper. So I'm just going to trace BC and then move it up like so. Okay, that's how I'm going to do it. But just draw a line up here, try to make it as parallel as possible to BC. And then I'm going to put an endpoint on it here. And an endpoint on it here. And I'm going to name them, how about JK? And if this is a vertex B, let's call this angle B, so we don't have to write as much, B degrees. And this is C degrees. And this is A degrees, using lowercase letters. So A, B, C, and then how about we call this D degrees, and this one E degrees. Okay, so there's our diagram with an auxiliary line that is parallel to BC. Okie dokie? Okay, so that was the first thing we do, and that's what we tell our readers we did. Okay, so I said draw an auxiliary line JK so that JK is parallel to BC. Okay, one little correction on this. These say line JK, line BC. That's a line segment. That's a line segment. This should just have a line over the top without arrows. Okay, like so. And now JK is parallel to BC. Segment JK is parallel to segment BC, and that was a construction. Okay, so now we look at our diagram and we try to determine what's going on here. So we have an angle D degrees, A degrees, E degrees. We have three angles on a line, and we know that that would add up to 180 degrees. So that's my first statement. I'm going to say D plus A plus E equals 180 degrees. Okay, now keep in mind what we're trying to remember. Alternate interior angles, corresponding angles, vertical angles. What do we have here? Well, if I have JK and BC as parallel and AB is a transversal, then hopefully you can see that we have this angle here and this angle here are alternate interior angles. So now I can say B equals D. And the reason, okay, so B is equal to D. And doesn't the same go over on the other side? So let's just change colors here to purple. Isn't E congruent to C for the same reason? So now I can say E is equal to C reason. Okay, same. Alternate interior angles are congruent. Alrighty. So now I have D plus A plus E is 180 degrees. But B is equal to D, so I can replace D with B. And E is equal to C, so I can replace E with C. So what I'm going to do is take my first equation here, and since D equals B, instead of writing D, I can write B. Actually, let me do a different color. How about red? I haven't used red. So instead of writing D here, because they're equal, I'm going to replace D with B. Plus, A has to stay there because it doesn't say it's equal to anything. And E is equal to C, so instead of writing E here, I can write C. So B plus A plus C has to equal 180 degrees. Okay, and that is the substitution property of equality, and we have just proved that the three angles in a triangle sum to 180 degrees. Okay, page 3 brings us to some review. It says, let's review the theorems we have now proven. Vertical angles are equal in measure. A transversal intersects a pair of lines. The pair of lines is parallel if and only if 1. Alternate interior angles are equal in measure, or 2. Corresponding angles are equal in measure. Interior angles on the same side of the transversal add to 180 degrees. The sum of the degree measures of the angles of a triangle is 180 degrees. Side trip. Take a moment to take a look at one of those really famous Greek guys we hear so much about in geometry, Eratosthenes. Over 2,000 years ago, Eratosthenes used the geometry we have just been working with to find the circumference of Earth. He did not have cell towers, satellites, or any other advanced instruments available to scientists today. The only things Eratosthenes used were his eyes, his feet, and perhaps an ancient Greek equivalent to a protractor. Okay, you're probably wondering what I'm talking about here. So we have a video that is at this link. So watch this video to see how he did it and try to spot the geometry I've been using throughout this lesson.
Did you know that over 2,000 years ago, a Greek librarian used geometry to determine the circumference of the Earth?
Hi there. Eratosthenes find the circumference of the Earth?
What are the angle relationships between parallel lines and a transversal?
The concept of the Earth being a large sphere was not unknown to the ancient Greeks. An everyday observation, such as the disappearance of ships below the horizon, indicated that the Earth might be spherical or round. But how large was it? The person who figured it out was a librarian named Eratosthenes, who lived in Alexandria, Egypt about 300 BC. While looking through a scroll one day, he read that at noon on the longest day of the year, a vertical column cast no shadow in Syene, a city south of Alexandria. Eratosthenes knew that this did not happen in Alexandria. He thought to himself, how was it possible to have shadows in Alexandria and not in Syene at the same time of day? Eratosthenes figured out that the sun must be directly overhead in Syene, but not in Alexandria. Aha! Here was proof that the Earth's surface is curved. Using a little geometry, Eratosthenes set out to determine the circumference of the Earth and find out just how big it is.
Just like our pizza example, if our friend Eratosthenes could determine the central angle at the center of the Earth and the length of the edge or arc, then he could figure out the circumference of the Earth. Now, finding the length of the edge or arc was fairly simple math. Eratosthenes asked a friend to walk from Alexandria to Syene to measure the distance between the two cities. His friend estimated the distance to be around 800 kilometers, or about 500 miles. Finding the central angle, however, would take some geometry. First, Eratosthenes assumed, correctly I might add, that the sun's rays are parallel, since the sun is so far away. Check this out. In this diagram, we can see that there is no shadow at Syene, while there is a shadow in Alexandria. The line that is formed by the gnomon, or vertical column at Alexandria, and the center of the Earth, cuts or intersects the two parallel lines formed from the sun's rays. A line that intersects two parallel lines is called a transversal. The two angles formed from the transversal line and the parallel lines are called alternate interior angles. And, according to geometric rule, they are equal. Let's prove it. Take a piece of paper of any width and draw a diagonal line on it. Label the angles A and B just like this. Now, cut the paper along the diagonal so you have two triangles. Compare angles A and B by placing one angle on top of the other. Hey, what do you notice?
The angles are equal no matter what size paper you started with.
Right. When two parallel lines are intersected by a transversal, the alternate interior angles are equal. Eratosthenes was quite a geometer. From his measurements, Eratosthenes calculated the sun's rays made an angle of 7.5 degrees at Alexandria. Now, since this angle was formed by two parallel lines and a transversal, the central angle of the Earth must also be 7.5 degrees. By knowing these two things, the central angle and the distance from Alexandria to Syene, Eratosthenes calculated the circumference of the Earth. 360 degrees divided by 7.5 degrees equals 48 slices of the Earth. Are you still with me? Okay, hang tight, we're almost there. Now, if you remember that the estimated distance between Alexandria and Syene is 800 kilometers, and you multiply that distance by the number of slices in the Earth, 48, what is the circumference of the Earth? Well, if you estimated that distance to be 38,000 kilometers, you're absolutely right. Eratosthenes' estimate was really close to the Earth's circumference, which is 40,074 kilometers. His percentage error was about 5% and was probably due to an error in the distance between the two cities. 5%? That's pretty good, considering Eratosthenes used only his feet, his eyes, his imagination, and of course, his knowledge of geometry.
Okay, that was a pretty cool video. So here this guy was around before the Common Era, over 2,000 years ago, and he estimated the circumference of the Earth. That was pretty amazing. Anyway, example 1. Construct a proof designed to demonstrate the following. If two lines are perpendicular to the same line, they are parallel to each other. A. Draw and label a diagram. So I want to draw two perpendicular lines to the same line. So here's how I would do that. Let's just do the perpendicular line in black. So let's do a segment. Okay, here's a line. Construct two lines perpendicular to this line. So then I can construct another one. Let's make them blue and make them perpendicular. So there are two perpendicular lines. So since they're perpendicular, I'm going to label them as being perpendicular with these angle measures. So it says, draw and label your diagram. So if I label it, I would call this A, B. So this is segment AB. This point C, this point D, so that's segment CD. This point E, this point F, so that's segment EF. And then I'll label this vertex or point of intersection G, and this point of intersection H. So I drew and labeled the diagram, step A. B, state the given facts and the conjecture to be proved. Okay, so I have that right here. So we are given segment AB is perpendicular to segment EF, and we're given CD is perpendicular to EF, and we're trying to prove that AB is parallel to CD. So a parallel symbol looks like so. Put a little arrow on both segments. So that's what we're trying to prove. There's B. And C says write out a clear statement of your reasoning to justify each step. In other words, do a two-part proof. Okay, so here it is, statement, reason. So we are already given, I just listed my givens, AB perpendicular to EF, CD perpendicular to EF, reason given. Okay, so now what are we going to do? Well, how about we just state what we labeled? So I said that this angle here is 90 degrees. So how about we just say angle, the measure of angle AGF is 90 degrees. And while we're at it, we could also say CHF is 90 degrees. Reason. Okay, perpendicular lines form 90-degree angles. Okay, so once we state that, well, if AGF is 90 degrees and CHF is 90 degrees, can't we now say that the measure of angle AGF equals the measure of angle CHF? Of course we can. Okay, so then we can say it's because of the transitive property. Since they're both equal to 90 degrees, they're equal to each other. And that basically sets us up to prove that AB, segment AB, is parallel to CD. I can now say that. So I can say AB is parallel to CD. Reason? If two lines are cut by a transversal such that a pair of corresponding angles are equal in measure, then the lines are parallel. So as you can see in this diagram, this corresponds to that. So they're parallel. Okay, page 4 brings us to a discussion, but before I go any further, it says here that each of the three parallel line theorems has a converse or reversing theorem as follows. So keep in mind from back in 8th grade, you did some logic, and you have a hypothesis that results in a conclusion. Hypothesis, then conclusion. If, then, remember that? If P, then Q, remember these? Okay, so converse simply states that if P, then Q is true, then the converse is if Q, then P. So we're just saying the conclusion as the hypothesis, and the hypothesis is our conclusion. So the original says, if two parallel lines are cut by a transversal, then alternate interior angles are equal in measure. We can also reverse that now and say, If two lines are cut by a transversal such that the alternate interior angles are equal in measure, then the lines are parallel. See how we're saying it backwards? So this one says, if corresponding angles are equal in measure. Okay, it says if two parallel lines cut by a transversal, then corresponding angles are equal in measure. If two lines cut by a transversal such that the corresponding angles are equal in measure, then the lines are parallel. If two parallel lines are cut by a transversal, then interior angles on the same side of the transversal add up to 180 degrees. Converse to that is, if two lines cut by a transversal such that the interior angles on the same side of the transversal add up to 180 degrees, then the lines are parallel. Okay? So now it says, notice the similarities between statements in the first column and those in the second. Think about when you would need to use the statements in the second column. That is, the times when you are trying to prove two lines are parallel. So here's an example. In the figure to the right, x equals y. So I'm going to label this with one arc and label this with one arc. Like so. That tells us that those two are equal in measure. We want to prove that AB is parallel to EF. So our goal is to be able to label this as such. Okay, so here's my statement reason set up. And so the first thing I can say is x equals y. Reason given. Okay, x equals y. And then I can go right and say segment AB is parallel to segment EF. Why? If two lines are cut by a transversal such that a pair of corresponding angles are equal in measure, then the lines are parallel. See how quick and easy that is now? 2 steps, boom, given, statement, reason, done. Okay, page 5 brings us to the end of lesson 11. Go to your problem set.